Okay, we're on to Unit 7. This is going to be 5.1. Okay, this takes a long time to get through this unit. Okay, you got to make sure you're keeping up on your assignments and everything. Okay, first one, you're going to learn a concept called rate of change. Determine whether each rate of change is constant, and if it is, find the rate of change with the label. So I put these tables on the paper. I'm going to make my table like this. I'm not going to draw boxes. So we got time, which is expressed in minutes, and then distance, which is expressed by miles. Okay, so your time goes from 1 to 2 to 3 to 4, and then 6 to 12 to 15 to 21 for the miles. Okay, when you're finding a rate, first you're going to make a division line. Okay? And what you're going to do is kind of do what you did when you wrote equations for tables in an earlier unit. You're going to start at, this is your x, this is your y. Okay? So you're going to start in your y column, okay, because the y is going to go on top. So you're going to take 21 minus 5, okay? 21 minus 5 is 6. So up here you're going to put 6 miles, put the label. And then in the meantime you go 4 minus 3, and that's going to be 1 minute. 1 minute, okay? We'll keep that rate there. Now you're going to generate a second rate. Okay, 15 minus 12 is 3, so you're going to go 3 miles, and then 3 minus 2 is 1, so 1 minute. Okay, then to the top, okay, 12 minus 6, that's going to be 6 miles. 2 minus 1 is 1, that's going to be 1 minute, okay? Okay, then what you do is just divide them. 6 divided by 1 is 6, 3 divided by 1 is 3, 6 divided by 1 is 6. So since they're different, okay, you didn't get all the same thing, you write not constant. Because this is 6 miles per minute, 3 miles per minute, 6 miles per minute, they're different, okay? Okay, example 2. You got pencils and cost. So pencils is going to be X, Y is going to be cost. So pencils 1, 4, 7, and 12. And then the cost, you got 25 cents, $1, $1.75, and 3. Okay? So your first rate, you take 3 minus 175, so it's $1.25. So it's going to be 1.25. Put a dollar label on it, but while that's happening, 12 minus 7 is going to be 5. So $1.25 over 5 pencils. Okay, then $1.75 minus 1, that's going to be 75 cents. Okay, so you put 75 cents in the numerator on your rate. 7 minus 4 is 3, 3 pencils. Then finally, okay, $1 minus 25 cents is going to be 75 cents. And then 4 minus 1 is going to be 3 pencils. Again, you're just minusing. You're making rates then. Okay, now I'm going to divide. $1.25 divided by 5. Okay, you get 0.25. Then 75 cents divided by 3. Oh, 0.25. 75 cents, well, I just did that one. That's going to be 0.25. So this time we have a constant. And when it's constant, you put equals, and you put 0.25, and then you need to include your label. Here's how you label that. The tops, what was their label? Dollars. The bottoms, what was their label? Pencils, but put it in singular form. Dollars per pencil, okay? So that's how you're going to write that. The constant is 25 cents per pencil. Cost per pencil. So when it is constant, you put that it's constant, you put what the constant was, the constant rate, per pencil. Now I'm going to show you what the point of that is, because you see your pencils skip 1 to 4 to 7 to 12, okay? That means if you just go by ones and go 13, 14, 15, then it goes up 25 cents every time. You don't need to take notes on this, but so it'd go to 325. Then it'd go to 350. Then it would go to 375. See, once I find that constant, then I can just up it by ones and go from there. So the constant 25 cents per pencil. Okay, last one of these. It's really not too hard. I mean, it's a little bit time consuming, but time expressed in minutes and then elevation expressed in feet. Okay, time 0, 2, 5, 12, and then 30,000, 29,000, 27,500, 24,000. Okay, now you need to find if the rate of change is constant, and if it is, what is it? Okay. So again, a rate of change means if you could just label that 12, 13, 14, 15, what would happen over here? That's what you're figuring out. Okay, so first you go 24,000 minus 27,500. Negative 30, you need to put the negative, okay? So negative 3,500 feet, okay? Then 12 minus 5 is 7 minutes. Okay, feet, minutes. Okay, 27,500 minus 29,000. It's going to be negative 1,500 feet. Then 5 minus 2 is 3 minutes. Okay, and then the last one, 29,000 minus 30,000 is going to be negative 1,000. Oops, I should have put. So that's going to be, this minus this is going to be negative 1,000, because from here to here it goes down 1,000. Okay, feet. Then 2 minus 0 is 2. Okay, now divide all of them, see what you get. They look like they might be different, but actually that's why you divide. So you got negative 500. Negative 500. Negative 500. So it's constant again. You got the same rate on all of them. So you write constant, write what it equals, negative 500, and then you label it, okay? You just put feet, minutes, feet per minute. Okay, and what the point of that is, if I went 13, 14, 15, I just add negative 500 every time for my feet, every time the minutes increase by 1. So 23,500 here, 23,000, 22,500. So that's what a constant rate would do. Okay, so that's the first thing on that agenda. Now here's the second thing. You're going to be introduced to a new term for a graphed line. It's known as the slope. Okay? Slope equals rise over run. It's a ratio. Okay? Now, this is how we're going to figure out the slope of the line. I've drawn 2 points. The point over here, okay, the point furthest to the left. This is left, this is right, okay? The point here, label it with a number 1, and this point, label with a number 2. Okay, here's what you do. You're going to find your rise. You start it here and you make a straight vertical line up or down till you're straight across from point 2. So I'd have to go up. okay? So I count by positives, positive 1, positive 2, positive 3. Now I'm straight across, so I put 3. So your rise is 3. Now your run, that's forward, 1, 2, 3, 4. Okay, you want to move forward after that, so it's 3/4. Don't divide that. Now you keep it as a fraction, make sure it's reduced. It is. Slope's 3/4. Okay, we are starting with, this is going to be point number 1. Okay, that is furthest left, this is right. Whatever point is closest here to this end of the graph, that's point 1. And this will be point 2. So again, a slope is rise over run. Okay, so this time we'd have to move down. That's fine. So the rise is going to be expressed as a negative. So down 1, 2, 3, 4, 5. So negative 1, negative, I count by negatives when I go down. Negative 1, negative 2, negative 3, negative 4, negative 5. So negative 5 is your rise. Okay. The run is 2. Okay. So negative 5 or 2, don't divide that. Okay. When you're dealing with a slope over a graph, you're not going to divide it. You're going to leave it as in fraction form. Now, I want it in improper fraction. Okay. I don't need that. 5 and 2 have no common factors where you could divide to reduce it, so leave it in improper fraction form. Okay, I don't want it as a mixed number. That's not a slope. Okay. Okay, which point's closest to the end of the graph from your left? It would be this point here. That's point 1. This is point 2. You start, so rise. Well, we'd have to go up, positive 1, positive 2, then I'm straight across. So positive 2 is your rise. Then 1, 2, 3, 4, 5. Okay, so 2/5. That can't be reduced to 2/5 is in simplest form. All right, now here's the left, okay? This is the point closest to the end of the graph from the left, and this would be 2. So, rise, well, I'm going to have to go down, okay? So I count by negatives. Rise over run. So negative 1, negative 2, negative 3, negative 4. So negative 4 is going to be our rise. Then our run, we'll pop 1, 2, 3, 4, 5. Okay, so negative 4/5 is going to be my slope. Okay. All right, that's all I have to say on that. That is 7.1.